this is Zach Dickens, and this is trigonometry behind lacrosse. In lacrosse, we have something known as a shooting angle, which is essentially the angle at which a person can see the face of the goal from any spot on the field. The closer you are to the center of the field, or the right-of line as we call it, the higher shooting angle you have and the higher chance of scoring. The further away from the right-of line, the lower shooting angle you have and the lower shooting angle, and the lower chance that you have to score. Shooting angles are an integral part of lacrosse, and understanding them is highly important to being able to play lacrosse on the offensive side. Knowing the chances of you making the goal are extremely important when you're shooting. The angles are highly variable depending on how close you are to the right-o line, and radians can be used to determine a more accurate shooting angle, as radians are essentially a more accurate representation of angles than degrees. In this example problem, we are given a shooting angle of 30 degrees. In order to graph this, we would go just less than 45 degrees, showing the proper rotation, labeling it, and showing that is in the first quadrant. Now, we can simplify this, or actually we can complexify this by converting it to radians. To convert it to radians, we would multiply the 30 degrees that we're given by pi over 180. In other words, 30 over 1 times pi over 180 come out to 30 pi over 180. You can simplify this, canceling out those zeros. 3 pi over 18. This isn't fully simplified. We could go to 1 pi over 6. Technically, this is fully simplified, but we could make it prettier by just doing pi over 6. Pi over 6 is the best representation, or the most accurate representation of the shooting angle, 30 degrees. And that is how trigonometry can apply to lacrosse.